the rule of implication introduction is a particularly difficult rule to understand. Its general formulation is this, so we abbreviate it as implication introduction. So suppose you assume a formula phi, and then you, through various steps in your derivation, various steps, various applications of other rules, you arrive at the formula psi. Then the rule of implication introduction allows you to write immediately below this last line, phi implies psi. So you can write implication introduction here, meaning that these steps in the derivation from here to here is due to the application of this rule of implication introduction. There are a couple of things to note here. The first thing to note is that we have here a horizontal arrangement where you have psi as your assumption and then phi as your assumption and then psi as the end of your derivation right above the line. And then this vertical relationship is then turned into a horizontal relationship where the assumption here, phi, becomes the antecedent of your implication. And what you have immediately above this line becomes the consequent of your implication. So you're turning this vertical arrangement into a horizontal arrangement. So that's the first thing to note, just as a general kind of spatial structure of the rule. The second thing to note is that since you have placed this assumption here as the antecedent of your implication, you have incorporated your assumption here. And remember that this statement here is an if-then statement. If phi, then psi. And when you assume something, you essentially say, well, if this is the case, then blah, blah, blah. So this is your assumption part. So it's all natural that you would put this assumption as your antecedent. But once you do that, once you incorporate your assumption in the antecedent, you can also cancel it because you have incorporated as part of your antecedent here. So that's the second thing to note. You can cancel, you should in fact cancel your assumption up here. Now, when you do that, it's important to keep track of which assumption you're canceling thanks to what applications of the rule of implication introduction. And so if you call, let's say, this assumption number 3, then you should repeat the number 3 here so you can keep track of what you're doing. So this is a general form of the rule of implication introduction. We can now see a couple of examples. Example number 1. Suppose you have assumed phi, okay, and you've called your assumption number 1. And then in the next line of derivation, you're simply repeating phi. You can do that through the rule of reiteration. This is a very simple rule that you can always use, right? Okay, we have our assumption phi. We repeated it in the next line of the derivation. What can we do? We can, in fact, apply our rule of implication introduction. So if we apply our rule of implication introduction, we can write in the new line, phi implies phi. Why can we do that? Well, we can do that because we have phi as our antecedent here. So you see that phi now plays the role of our antecedent. So this is the assumption 1 that becomes the antecedent. And then what's immediately above this last line can be the consequent of our implication. And so we've perfectly followed this structure of the rule here. What's peculiar here is that we have 2 instances of phi. So this shouldn't confuse you the two phi, they are the same, but they play different roles, because one is the assumption that then becomes the antecedent of your implication, and one is at the bottom of the derivation, immediately above this line, and becomes the consequent of the implication. Finally, since we have used this rule of implication introduction relative to assumption number one, we should keep track of this, so write number one here, and we can cancel it. Here's a second example, a little bit more complicated. So example number two. Suppose we assume another formula, let's say psi. We call this assumption number one. We always need to keep track of our assumption. And in the next line of our derivation, we write another formula, let's say phi. And we also assume it, and we call this assumption number two. Can I do that? Can I assume psi, labeled 1, assumption 1, and then in the next line of derivation assume another formula, phi, and label it number 2? Yes. You can assume anything you want. There is no limit to the assumption you can make. Of course, there is a limit to the assumption that you can cancel, that you can eliminate, but you can assume anything you want. So we have assumed that. Now, once we have assumed that, we can do a couple of things. First, we can apply the rule of implication introduction to our first assumption up here. So we keep track, we're applying to our assumption up here, so number one. And we can write phi implies psi. Now we have followed the structure of the rule of implication introduction, which is right here, because our assumption becomes the antecedent of our implication, and what we have immediately above this line becomes our consequent. It doesn't matter that this is another assumption. We're just following the general form, the general structure of the rule. And since we have put this assumption psi, assumption number one, as the antecedent of our implication, we can cancel it. We're keeping track of which assumption we are using, and so this is good. The second thing we can do, we can apply our rule. So we can apply our rule of implication introduction a second time, so implication introduction, this time to our second assumption here, so number two. And so we're going to write this assumption as our antecedent, phi implies, and then we're going to repeat what we have immediately above the line, psi implies phi. Let's check just to make sure. So we have applied the rule of implication introduction to our assumption number two, and so this assumption number two has become the antecedent of our implication. That seems correct. And what we have immediately above the line, namely this implication here, becomes the consequent of this implication. Now, one should not be confused by the fact that this psi implies phi is itself an implication within a larger implication, is a nested implication, as it were. But this shouldn't confuse us, because we're still using the general form of the rule of implication introduction, which is up here. We have our assumption that becomes the antecedent, and what's immediately above the line becomes the consequent of the rule. And we have the same here. Our assumption number two becomes the antecedent, and what's immediately above the line becomes the consequent. It doesn't matter that what's immediately above the line is itself a formula in the form of an implication. Okay, since we have applied the rule of implication introduction to our assumption number two, we've put it as an antecedent, we can cancel it, and so we've gotten a derivation of phi implies psi implies phi. And we're done.